Hi again everyone, Chris Tisdell here again. In this presentation, I'm going to continue my series of videos on complex numbers. Now in previous presentations, I showed you de Moivre's formula or de Moivre's theorem, and I did a trig, I proved a trig identity using it involving cosine. Now in this video, I'm going to do a similar example but using a trig or proving a trig identity involving sine. So let me share my screen with you and we can get underway. Okay, so we're asked to write sine 4 theta in terms of cos and sine by applying de Moivre's theorem or de Moivre's formula, and hence write this product as a function of sine. So how do we do it? Well, first of all, let's refresh our memory on what de Moivre's formula or de Moivre's theorem is. If n is an integer and theta is real, then this is the formula, okay? Now, for this particular, the first part of this problem, we've got sine 4 theta. So in here, you would have n equals 4. So the very first step for these kinds of problems is working out what value or which value of n you're going to use de Moivre's theorem or de Moivre's formula with. Okay, so let's start with that. We want to use n equals 4. I'm just going to abbreviate de Moivre to dm's. So by de Moivre's formula with n equals 4, we have the following. Okay, so so we'd have a 4 up there, a 4 in there, and a 4 in there. Okay, so we have sine 4 theta as the imaginary part of the right-hand side. Now, because these two expressions are equal, the imaginary part of this side must equal the imaginary side of this thing. We don't know what that is yet, but we will work it out. Okay, so we're going to equate the imaginary parts. They're basically the coefficients of I. Okay, so sine 4 theta will equal the imaginary part of whatever that is. So for imaginary part, I'm going to put IM. So we don't know what it is, but we will work it out. And once we've worked it out, we'll have our identity. Okay, so you've got this raised to the power 4. How do we do it? Well, we are going to use, say, Pascal's triangle. Okay, so with Pascal's triangle, it's essentially an algorithm for expanding these kinds of expressions. Okay, so you start with this, and then ones are all down the sides of this triangle, and to form a number here, you would add these two expressions to get 2. You would add these two expressions to get 3, these two to get 3, etc. Okay, and the ones are always down the outside column. Okay, so 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, and this is the power 2, power 3, power 4, so I can stop there. It's a Pascal's triangle. Okay, so the numbers here give you the coefficients of the expansion. All right, so let's expand this and see how we go. So let's start with cosine theta. Well, that's the coefficient, and you raise it to the power 4. And what you do is you decrease this power and increase the power of the other term. Okay, so the 4 comes there, that's going to be the coefficient. You decrease this power by 1, and you increase the power of the other term by 1. Okay, now the powers should always add up to 4. Okay, so that's a little check. Okay, let's move on to the 6. So I decrease this power by 1 and increase this power by 1. So we'll get a cos squared and an I sine theta all squared. Yeah, so move on to the next one. Decrease this squared by 1, so I'll just get cosine, increase this power by 1. And lastly, decrease this power by 1, so that'll disappear, and increase this power by 1. Okay, and we want the imaginary part of this mess. Okay, now it looks a bit crazy now, but all we have to do is cherry pick the imaginary parts out of here. So that has no I associated with it, so we can forget about that. That will have an I associated with it. Remember, I squared equals -1. So that'll become a real number, so we can forget about that. I cubed, that will become -I. So this will be something we're interested in. I to the power 4, that will become a real number. So let's go through and cherry pick out those parts. So this will be what we want for cos cubed times sine. Okay, you don't write down the I because we only want the imaginary part there. And this one here, so I cubed will become -I. So I'll get -4 cosine theta sine cubed. Okay, so we have done the first part of the problem. We have obtained sine 4 theta in terms of cosine theta and sine theta. Okay, so the next part is writing this product as a function only of sine theta. So what I can do is take this, multiply both sides by cosine theta, and then hopefully it will simplify. Okay, so let's do that. Okay, sine 4 theta cos theta. I'm just going to change pens. Okay. All right, so we take all of this and multiply through by cosine theta. So I'm going to get a cosine to the power 4 there and a cosine squared there. Okay, but I still don't really have what I want because I only want this this part in terms of sine theta. I've got cosines in there. But what I can do is use, cosine squared equals 1 minus sine squared. Okay, so here I've got cosine to the power 4. That's cosine squared squared. So I can write it like this. And this is a bit simpler. Okay, so now I've got sines here. It's just up to me to simplify it now. Okay, now if you expand out these brackets and do the simplification, you will get the following. Okay, so I invite you to just put in I think it's one line. Oops, yes. Okay, so I've now got this as a function in basically of sine theta. Okay, so a good question now is why would you want to do something like that? What is the significance in the question and what you're actually doing here. Well, one way of doing it is thinking about, say, integration. Okay, suppose you were wanting to integrate this expression. Okay, well, you can do it. It's not that difficult, but it's far, if you know that this equals this, it's far easier to integrate that than that. I mean, it's not too bad to integrate this, but it's far easier to integrate this. So one motivation for studying de Moivre's formula or de Moivre's theorem is that it can make your life simpler with calculations, and integration is one example. Okay, that's my presentation. Hope you enjoyed it. Hope you found it useful. In forthcoming videos, I'll be continuing my series on complex numbers. Hope you can join me. If you have any comments, any questions, feel free to post a comment. So thanks for watching. Hope to see you soon. Bye.